What's up, what's up, what's up, everybody? Good morning. Today, we're going to continue with probability. Today, we're going to talk about something called mutually exclusive, or another name for mutually exclusive is disjoint. We are going to talk about all those terms, disjoint events or mutually exclusive events, and something called the addition rule. So, set A has 15 items, set B has 20 items. In total, both sets have 30 items. Now, I'm not a mathematician, no pun intended here, but that wasn't a pun in the first place, but 15 plus 20 does not equal 30. So what's up with this? So this entire set, A, has 15 items. Notice I'm writing 15 on the outside of the circle. Set B has 20 items. So I know that all together, these three sections right here, section 1, section 2, section 3, or sliver 1, sliver 2, sliver 3, those three slivers add up to 30. So I know that 20 plus 15 is 35. 35 minus 30 gives me 5 extra numbers. Where shall I put those 5 extra people or numbers that are apparently, I guess, part of both circles? How about right here in the middle? And then I could do some simple subtraction. I know that this entire circle, I'll use the cursor, adds up to 15. But if 5 people are already in that circle, 15 minus 5, and I'll write that out. 15 minus 5 leaves me 10 people right there. And if I do the same thing, 20 total people minus 5 leaves me 15 right here. Does 10 plus 5, which is 15, plus another 15 give me the 30? Yes, it does. By the way, this is called a Venn diagram. And we have just created a Venn diagram right there. Good job. Set C has 25 items. Set D has 10 items. But notice there's no intersection here. They don't overlap. So set C just has 25 items, and set D has 10 items. Now, what do these symbols mean? Normally we go through Venn diagrams before talking about this, but the intersection symbol is this symbol. It stands for intersection. The upside down U. In layman's terms, it means and. What is part of A and B? What does and tell you to shade? What's only common to both? The union symbol is like a U. In layman's terms, union means or. And the union tells you to take everything. What does everything mean? It means what's common plus what's unique to each one. Oh, unique. Common plus unique. I know that's kind of sloppy. So what numbers are part of A and B? Well, that's just the 5 people that are part of both circle A and circle B. How many numbers are in circle A or circle B altogether? Well, that's just the 10 plus the 5 plus the 15. You add up the numbers inside because the 10 and the 15 are unique to each circle, and the 5 is common to both. Add them all up. Or means everything, and you get the 30. How many numbers are part of C or D? Well, that's just 25 plus 10. Or means anything, or means everything. So 25 plus 10 equals 35. How many are part of C and D? Well, is there any overlap right here? No, there's no overlap. So C and D is just 0. Circle C and D represent mutually exclusive events. 2 events are mutually exclusive if they cannot occur together. In other words, they have no common outcomes. They have no common outcomes, nothing in common. Circle A and B have these 5 people in common. Circles A and B have these 5 people in common. Circles C and D have nothing in common. Nothing. They will never date each other. Gosh. All right. So event A, let's say that event A is drawing a red card from a deck of cards. And event B is drawing a club from a deck of cards. Now, again, for those that are not familiar with card distributions, use your reference sheet. So red cards are hearts and diamonds. Clubs are black cards. Can a card be both a club and a red card at the same time? Absolutely not. They cannot. So those are called mutually exclusive events. Being a club and being a red card are mutually exclusive events because a single card cannot be both red and a club at the same time. So what's the probability of being both red and a club at the same time? 0. What's the probability that a card is a red or a club? Or means to add up everything. How many red cards are in a deck? Half the deck's 26 out of 52. Plus, how many clubs are in the deck? Well, the clubs are a suit, so that's 13 out of 52. There's nothing in common, so 26 plus 13 is 39 out of 52, which, by the way, that's 3/4. Okay. If two events are mutually exclusive, then the probability of A or B, and I'm going to write the word or there, simply equal to taking the probability of A and taking the probability of B and adding them together. That's exactly what we just did right there. Okay, I'm not going to do the sheet necessarily in order, and I'm not going to do all the problems. I am simply going to work this out right now. So I'm going to work it out in a certain thing. I'm going to do example 1 first. Find the probabilities when rolling 2 dice. Again, when rolling 2 dice, use your reference sheet. Use your 2 dice chart. Rolling 2 dice, that means there are 36 possible outcomes. Okay, I will toggle back and forth between the sheet here. What's the probability that the sum equals 7? So right off the bat, I know that my denominator is going to be 36. So how many 7s are there? Well, to find this particular sums, you go along the diagonals here. So let me use red this time. Aren't these all the 7s right there? How many are there? 1, 2, 3, 4, 5, 6, 7. So let me go back. There are 6 7s out of 36. Oh, what stayed in the red right there. So that reduces to 1/6. How about the sum is 7 or the sum is 11? I already know that there are 6 7s out of 36 plus, and I'm just going to cut to the chase without going to the other sheet. There's 2 11s out of 36. The reason I'm adding is because I see or means to add up everything. And that leaves me with 8 numbers out of 36, and that reduces to 2/9. Wow, this addition rule is not too bad. And by the way, now you know what's called the addition rule. Or means add. How many 11s are there? 2 out of 36. I guess I should have done it in order, everybody, right? So that's 1 out of 18. Done. And last but not least, what's the chances that the sum is 7 and the sum is 11? Well, if I roll 2 dice, can I roll 2 dice so that the sum equals 7? The 2 numbers add up to 7 and the 2 numbers add up to 11 at the same time? No, that's impossible. So there's no way that I could roll a sum of 7 and a sum of 11 at the same time. They are called mutually exclusive events. Okay. Things get a little more dicey when I do number 2, specifically 2A. What's the probability that I draw 1 card from a deck? Okay, it says when a card, so that's just 1 card. Can that 1 card be both a red or a queen? Well, let's see here. How many red cards are there? There's 26 out of 52. And I'll do plus right now because or means plus, everybody. How many queens are in a deck? A queen is a type of or specific card, so there's 4 queens: hearts, diamonds, clubs, spades, out of 52. My question for you is this: should I just add 26 plus 4 and get 30? Should I do that? And the answer is no, I shouldn't just do that. Why? Are there cards that can be both queen and red at the same time? Are there red queens, in other words? Yeah. There's the queen of hearts and there's the queen of diamonds. I added the queen of hearts and the queen of diamonds in these red cards, didn't I? Because they're both red. I also added the queen of hearts and diamonds in these queens because they're both queens. So I like those two queens, but I don't like them twice as much. So I need to subtract away the two queens that I counted twice. So everybody, to put this in notation form, this is the probability of being a red card, plus this is the probability of being a queen, minus who are these two cards? As Seinfeld might say, who are these people? Who are these cards? All right, well, they're the red queens. But let me write that a different way. Aren't they the cards that are both red and queens at the same time? That's exactly who these two cards are. And I don't end up with 30 out of 52. I end up with 28 out of 52. And that reduces to 7/13. How many cards are both red and queens? Well, my friends, we just answered that. Aren't these two cards right here both red and queens? Yes. Part B was already answered for us. They are the two cards that are both red and queen. That reduces to 1/26. Okay. How about a black king or a club? How many black kings are there? There's the king of clubs and the king of spades. So that's two cards out of 52. 52, sorry. 4 means plus. How many clubs are in the deck of cards? There are 13 clubs in a deck of cards. Use your reference sheet. Have it out while I go through this. Can a card be both a club and a black king at the same time? Yes, it can. How about the king of clubs? Isn't the king of clubs both a king and a club? Yeah. How many cards is that? Just one. The king of clubs is one card. So minus the one card, the king of clubs, that we counted twice. So this is the probability of being a king plus the probability of being a club, you find me in a club, minus the probability of being both a king and a club at the same time. So 2 plus 13 is 15. 15 minus 1 is 14 out of 52. And so that becomes 7/26. Once again, king and a club, I've already answered it. It's right here. This is the answer to part D. This is the one card that is both a king and a club at the same time. Two more problems like this, and I'll call it a lesson. An even number or a black card. All right, even numbers are 2, 4, 6, 8, and 10. And there's 4 of each of those. So 4, 8, 12, 16, 20. So that's 20 out of 52. 4 means plus. How many black cards are in the deck? Half the deck is black, so 26 out of 52 minus. Of these even numbers, how many of them are black? Well, the clubs and the diamonds, I'm sorry, the clubs and the spades of each are black. So half of these cards are red and half of these cards are black. So half of the 20 cards are red and half of the 20 cards are black, which means I need to subtract away the 10 cards that are both black with an even number on them. Again, it's the probability of being even plus the probability of being a black card in the deck of cards minus probability of being both an even number and a black card on it, and a black card, clubs or spades. So that's 46 minus 10, which is 36 out of 52. 36 out of 52 reduces to 9/13. Once again, the answer to part F is right here in part E. Even number and a black card, they are just the 10 numbers out of 52 that are part of both groups. So that's 5 out of 26. Last but not least, a red face card or a jack. First off, what are face cards again? Face cards are jacks, queens, and kings. That's 4, 8, that's 12 cards. But of those 12 cards, 6 are red and 6 are black. So there are 6 red face cards out of 52. 4 means plus. How many jacks are in a deck of cards? Well, there's 4 jacks. They're right there. So plus 4 out of 52. Can a card be both a jack and a red face card? Yes, it can. How many of these red face cards are jacks? Two of them, right? The jack of hearts and the jack of diamonds. So two of these red face cards are also jacks. So -2 out of 52. So that's the probability of being a red face card plus the probability of being a jack minus the probability of being both a red face card and a jack. So 10 minus 2 is 8 out of 52, which is 2 out of 13. And last but not least, the answer is there to part H. How many are red face cards and jacks? Just these 2 out of 52 cards, which is 1 out of 26. So to finish up our lesson, let me actually go back up, believe it or not. If two events are not mutually exclusive, in other words, if an event can be part of both groups, what you do is you subtract off that piece that can be part of both groups, and that is the answer to the question, what's part of both or and. So the probability that A or B occurs in general is equal to the probability of A plus the probability of B minus the probability that A and B both occur. Ladies and gentlemen, this formula in red is the formula you should use as the addition rule formula no matter what. If two events happen to be mutually exclusive, then this piece is just 0. If they are mutually exclusive, this piece is 0 because there's no way that if two events are mutually exclusive that they can occur together. All right, everybody, your job is to do the homework. If you see the word or means to add. That's the bottom line. If you see the word or means add, and then whenever you add, ask yourself, is there anything common to both? And if there is something common to both, subtract it off. That's it, everybody. Questions? Ask me. Bye.